If we are in the earlier stages, usually we have at least the process flow diagram. It is the responsibility of the process engineer to build that, and we have the plot plan of the project. So an example of plot plan you can see here, and this reference is from Have Baron presentation, and you can find his full presentation in the slide share also. So some comments here. First, when we are talking about engineering documentation, we always have a stamp, and for sure he removed the stamp only for the purpose of his workshop. And what matters here is that we have a top view of the system. So let me use this here. So you can see that we have the distribution of the equipments in the plot plan. And here at the bottom, it's probably the cooling water system or cooling tower system. And you can see that there are a number of cells here. And let's suppose that we are talking about installing a cooling tower system, and you need to size and select the pump for the new plant or to the bottlenecking of the plant. In your plot plan, you will have the probably location of your pump or systems of pump. And in this case, it's probably close to the cooling tower system because you want to less pressure drop as possible from your source of liquid and your pump system. So here you have the pump, and you will have a series of equipments that must be cooling down during the process. So let's suppose here it seems we have a batch of heat exchangers. So we have E, so it may be exchanges, heat exchangers. So how you will do the preliminary calculations to define the pump head of your the head of your pump? You will need to get the plot plan. The plot plan is always scaled. So you can see here that you have a graphic scale 1 to 250, and usually it is in millimeters, and of course that it depends on the location where you are doing your plan design. If you are in the US, probably it will be in feet or in inches, okay? And what matters here is that with the plot plan, you will do, at preliminary calculation, you will do a straight line from the pump to the pipe rack, and another straight line from the pipe rack around the equipments that you will cool down, and another straight line to the equipment. So as it is a scaled document, you will be able to calculate, or you will be able to sum up the distance from your pump and the system that you must cool down. In this way, you will have the pipe length for this process. In the same way, if we are talking about cooling, we have the cooling water supply and the cooling water return. And probably it will do the same route. So you will return with the pipings, with the pipings to the cooling tower system. And with this, you have your total length of pipelines in the discharge of your pump. But not only that, you need to evaluate how is the elevation of the pipelines, because when we are talking about fluids, liquid fluids, as much higher is the pump needs to pump that, more heads are needed to the pump. So you cannot consider, it depends on the project. You can see if it has a pipe rack. The pipe rack usually is a structure that supports all the pipelines of a project, and it is not in the floor. It is elevated in order that people or equipments or moving parts can movement below the pipe rack. So another document that is very useful and usually we use during the preliminary stages of the plan design is the elevation view, and it is also from Have Baron, so you can download all of these from his slide share. Okay, so look for it in the LinkedIn. And let's see here, what is the differences between the elevation view and the plot plan. The plot plan show you the top view of the equipment, so you can see where is located each one of the equipments, and you can calculate the distance between them or among them. The elevation view is to let easier to you understand what are the elevations of the equipment. Here you cannot see the distance. If one is behind the other, you cannot see how much length you have from a tower from another. For instance, this tower here, it's in the front of this one. You are not able to identify what is the distance. You need the plot plan to do that. But to verify the elevation view, it's easier to you take. Sometimes we have that, sometimes the elevation is written in the own plot plan, and you have here the elevation. So it's I'm not so sure if it's in inches or if it's millimeters, but what matters here, as in the plot plan, it is also a scaled document. It must be scaled to show you how is the configuration of your plant. So you have here the elevations, and you are able to verify and do your sketch as we have in the Vijay Sarat's schematic. What is the elevation that you must consider, what is the size or the length that you must consider, and with that start your calculation to do the pump sizing and selection.